All right, so what we're doing today is we are trying to finish up the mixtures section, and we've got a slideshow there. Yesterday we did dilute and concentrated, correct?
Yeah.
Okay, but this class did not do saturated or unsaturated. You said you just finished it? Okay, can you remind me what saturated means? Yes? The full amount and you can't get any more. That is correct. So like if you have a lawn and somebody's been watering the lawn, and usually at the first the water soaks into the lawn, but eventually the water just puddles on the top because the lawn can't absorb any more water, that would be saturated. And then unsaturated would be when there's still room for more. The same thing works in solutions. If you put salt in, a little bit of salt will dissolve, and so it'll be fine. But eventually you can put so much salt in that it piles up on the bottom. Did I show you that yesterday? Okay. So there's our review for saturated and unsaturated. That means that solubility is the new vocab word that we start today. All right, everybody got their notes out? Everybody? Okay. Solubility is the amount of solute, that's the amount of powder, that's needed to make a saturated solution. That's the maximum amount in a given amount of solvent at a certain temperature. Basically, it's a number. All right. Annotate. Solubility is a number. It's the amount that will dissolve in 100 milliliters of water at a particular temp. It is the maximum. After that, all you get is powder on the bottom. Does this make sense? Has everybody gotten everything written down on this page that they need to? That's a no and an almost. Okay, so I'll wait here for a couple minutes. Yes, ma'am. This says is a number. Sorry. Is a number. This over here should say dissolve, and this word here is supposed to be particular. Ah. And this is supposed to be an M for milliliters. How are you doing? Can I switch slides? Not yet? If this is a video at this point, then if I'm running slow, somebody could pause it, because I'm going to stop. Here we go. All right, we're moving on to the next slide. There's a solubility chart that you need to be aware of. In your textbook, there's a solubility chart that you're going to have to read for the test. This is not the one that's in your textbook. The one in your textbook is actually simpler. All right, but let's go over how to read this. All right, what you do is you pick a line. So here I'm going to pick this line right here. Do you see this line that I'm tracing? All right. This line right here is the line for the compound potassium chlorate. All right, this right here, this is potassium chlorite, KClO3. Everybody with me so far? All right. The type of questions that I would ask about this chart would be, how many grams of solute will dissolve at 20 degrees for potassium chloride? So going up, is grams of solute. This is the grams of stuff that will dissolve. Grams of potassium chlorate in this case. Across is temperature. How you do it is you find, here's the temperature. I said the problem would have 20 degrees. Here's 20 degrees. You go up from 20 degrees until you get to the line. Here's the line. And then you go over from 20 degrees until you get a temperature, or grams. So in this case, it would be 10 grams of potassium chlorate at 20 degrees. Does this make sense? So let's pick something a little bit harder. I'm going to change colors here. All right. Here, let me ask you a question about potassium chloride. I'll trace the line for you so it's a little bit easier to see. All right. How much potassium chloride will dissolve at 40 degrees Celsius? Take a minute. Figure out an answer. I want everybody in the room to have an answer. So that means you got to be looking at the screen. Everybody in the room, I want an answer. How much potassium chloride will dissolve at 40 degrees? You're the only one with a hand up on this side. Yep. 40. 40 is correct. What you do is you go up from 40 degrees until you hit the line. Here's the line. And it's nice and convenient on 40. Let's do one more that's not quite as convenient. Let's do sodium nitrate at 50 degrees. Sodium nitrate at 50 degrees. How much will dissolve? Use fine. Around 114 is correct. So here's our 50 degrees. Here's our mark. Is this more or less than halfway? Less. All right, so it's 110, 120. Halfway would be 115. So this answer has to be more than 110 and less than 115 in order to be considered accurate. I would say anything between 111 and 114 would be considered acceptable. Everybody understand how to read this chart? There is a chart just like this on the test. If you are having difficulties with this, you need to come in and see me. Okay? So I can do a one-on-one with you if you want it. So that's the solubility chart. That's not what I wanted to do. No, you can't mark the line with color on the test. You're just going to have to kind of like dot it up with like a pencil maybe. All right? So that's the solubility in the solubility chart. Oh, there's something about that solubility chart I needed to show you. I'm sorry. Come on. Open. Okay. I want you to notice something. Most of these solid lines go what direction? Up. So that means, now notice that the solid lines represent solids. So if the line goes up, what happens to solids as temperature goes up? Do they dissolve better or worse as temperature goes up? Better. Okay? Because this means at 90, I've got more stuff that will dissolve than at 70. Now the catch is that these dotted lines are gases. And what do they do as temperature increases? They don't dissolve as good. Gases generally dissolve worse as temperature increases. So this is a general rule. All right? The rule is gases dissolve worse in high temps. And solids generally dissolve better in high temps. Now, I have to have the word generally here. Why?
Because there are a couple lines of solids that get worse when the temperature gets higher.
That is correct. There are a couple of lines of solids that get worse as temperature gets higher. Here's one right here. Do you see it? Most solids get better, but not all. So you have to say things like generally or most. Okay? Darn it. Okay. So we've already talked about the fact that mixing, heating, and crushing will affect how fast most solids dissolve. We talked on that yesterday. We've already talked about suspensions. We've already talked about the characteristic of suspensions. Today's lesson is a little bit more on colloids. Colloids are mixtures with medium-sized particles. We talked about suspension with big particles. We talked about colloids with medium-sized particles. All right? So colloids have properties of both solutions and suspensions. The particles are small enough that they won't get trapped in a filter, but they're big enough that they will reflect light. So just as a review, you want to kill the lights, please? So here's a Jello and Sierra mist. Jello. All right. And notice as I shine the laser beam through the Jello, it looks like there's a lightsaber in there. But in the Sierra mist, there isn't any. Oh, nope, that's because it's down on the paper. Sorry. If I do it out on the paper will reflect it. But all right. Now, even if I go from the other side, okay, that's because the Sierra mist is a solution, and the Jello is a colloid, which means the particles in the Jello are bigger, so they're big enough to actually reflect light. Yeah?
But if you put Jello in the filter, it'll just like...
It'll go right through. Now, you might need to melt the Jello so that it actually could go through the filter, because this Jello is kind of solid, and it probably wouldn't go through the filter, and none of it would probably go through in this state. All right? Yes? The question was, most colloids are a foam or a gel. Is that considered a solid or a liquid? And the answer is they are mixtures in which some of the ingredients are solids and some of the ingredients are liquids or even gases. So parts of it are solids, parts of it are liquids, and parts of it are gases. For example, here are our list of example colloids. Milk would be solids in a liquid. Gelatin is solids in a liquid. Whipped cream is solids in a gas, because there's like air in the whipped cream. Deodorant is solids in a gas. Sometimes it's solids in a Liquid, it depends on the brand of deodorant that you've got. Mayonnaise is a liquids in a solid. Other examples of colloids that you need to know are fog, which is a liquid in a gas. Smoke is a solid in a gas. And toothpaste, which is some solids in a liquid. It's not listed on the picture. They're just extra ones that might appear on the test, so perhaps you should write them down. Smoke, fog, toothpaste. A colloid. These are all examples of colloids. If you remember, the test is mostly multiple choice. So you might get, colloids are mixtures that can be made out of, and you might have gas and solid, liquid and solid. You might have choices like that, and probably end up being all of the above, because colloids have so many choices that they could be, that you might get several options and then all of the above. Yes, ma'am.
Can you go back to slide 4?
I can go back to the slide before this. Yes, ma'am.
But you said that the particles can go through the
They can, given the right conditions. They are considered to be medium-sized particles. So there is a possibility that you might have something that the medium-sized particles are. Sorry, I got a frog in my throat. A medium-sized particles is a big range. So you might end up with some colloid that doesn't follow the rules. But for the most part, they should be able to go through a filter. Okay? That is it for notes. Now I want to switch to the lab stuff. All right? For the lab, you may choose your own partner. There can be a group of 3 if there is an odd number of students in the room right now. But you need to include a plan for the absent student. So right now, we have 1 absent student in this particular class. So somebody needs to plan to include her so that when she shows up tomorrow, she has a group to join. So she'll be joining a group of 2 tomorrow. All right? So you guys got to figure out who's going to take in London and who's going to be in her group. Does this make sense? Okay. Your job is to look up the answers to the question on the front page of the lab and use the laptops to assist you. Then work on the next 2 pages. Okay? The front page, you might need the laptop. The next 2 pages, you should not. But you can still use them if you think you need to. As part of your team, you can work through the pre-lab directions in order. That's the next 2 pages. But don't forget to read the background paragraph at the top. You can divide and conquer if you so choose, having one person work on one page and having another person work on another page and then swapping information. Because you do want to try to get done during class, and there's only about 20 minutes left. The available materials will be filter paper, hot plate, hot mitts, beakers, paper cups, funnel, magnet, baggie, water from the sink, sand from the salts, and the sand, salt, and iron mixture. And you'll be also asked to make a flow chart. A flow chart looks like this. You're going to start with a container that's going to have your iron, sand, and salt. Then you're going to do something. Okay? You're going to write whatever that is that you're going to do here on the line. That doing something should split up your iron, sand, and salt into at least two groups. One group might be sand and salt. And then the other group is probably going to be your iron. Once you have the iron by itself, that one's done. Is sand and salt by itself yet? No. So then you have to do something else. Should you be writing do something here, or should you be writing what it is that you're actually choosing to do? What it is that you're actually choosing to do. And that something should separate it out into two more. One should be sand, and the other one should be salt. This is a flow chart that shows what you're planning on doing. You'll end up doing two of these before the lab is over. All right, you'll do one today, and that's your plan. And then you'll do one after the lab is over that shows what you actually did. Because sometimes, you know, your plan and what you actually do aren't the same. If they are the same, then you have two of these that are identical. If they're not the same, then you have two of these, but they're not the same. You don't get docked if your plan beforehand isn't perfect. Yeah?
Are we trying to get this done today?
You are trying to get through pages 1, 2, and 3 today with your partner. You're not actually doing the lab today. You'll actually do the lab tomorrow. Does everybody understand what they need to do? Off you go.